Consuelo Mathletes. Okay, this is what we've done so far. We have found logarithms. Well, first of all, you have to be able to change from log form to exponential form if you need to. Most of the time, you don't need to. Okay? And then we've evaluated logarithms, found logarithms, and then we've graphed. Okay, that's what we've done so far. So what else could we need? Well, eventually, we'll need something called the log rules. And I'm not going into the theory of why these log rules work, but basically notice the arrow I have between them. Okay, it goes both ways. Sometimes you'll simplify with the log rules, and of course that's the option you want first. Okay, but sometimes you'll go from the expanded form to the simplified form. Sometimes you'll go from the simplified form to the expanded form. How do you know which one to do? Always try and simplify first. Well, first of all, try not to use log rules at all. But if you have to use the log rules, then go from the expanded form to the simplified form. And then if that doesn't help, which most of the time you'll never have to do this last thing, then go from the simplified form to the expanded form. Okay, here's the basic log rules. And I'm going to state what they are, and then I'm going to say the way you should really think of them. Okay, if you add logs, so number one, if you add the logs, you multiply the numbers. Okay? By the way, notice in the simplified form, there's only one word log. There's not two words log anywhere. Okay? The second rule says if you subtract the logs, you divide the numbers. Okay, those are the rules. That's not a good way to think of them. The way you want to think of them is this, and then I'll get to the third one. Okay, think of it this way. If there's a plus sign in front of the log, whatever you're taking the log of goes in the numerator. And if there's a minus sign in front of the log, then whatever you're taking the log of goes to the denominator. And I know this may seem like a weird way to look at it, but in the long run, it's much easier if you think of it this way. So notice here on the first example, what's the sign out here in front? It's plus. That's why the k is in the numerator, because this is like k over 1. Okay, what's the sign in front of the second log? It's a plus. That's why the m goes in the numerator also. So it's k times m. Notice on the second example, though, there's a plus, because it's positive, in front of the first log, so the k goes in the numerator. And there's a minus in front of the second log, and that's why the m goes in the denominator. And that's the way you should think of it. A plus in front of the log makes the value go in the numerator. A minus in front of the log makes the value go in the denominator. Now, what's the third log rule? Third log rule basically allows you to do this. Take a number that's in front of the log and put it up in the exponent. That's to simplify it. Okay? To expand it, you take the number in the exponent, which you're not going to have to do very much, and put it in front of the log. So I'm going to kind of ignore that one for now, but eventually we'll take a look at it. Okay? All right. So let's just take a look at some examples. Okay, these ones are written for you. Okay. What I'm asking you to do is simplify. So when we're done, we'll have one word log. Okay? So notice this whole line right here simplifies into one log right here. Okay? So how do we know where the x, where the y, where the 3, where the everything goes? Okay, first of all, there's no sign in front of the first log. Therefore, it's positive. That's why the x ends up in the numerator. There's a minus in front of this log. That's why the y ends up in the denominator. There's a minus in front of this log. That's why the z ends up in the denominator. And there's a plus in front of this log. That's why the k ends up in the numerator. So that's why those particular variables end up where they do. If it's a plus, I just look at it numerator, denominator. X, numerator, because it's got a plus. Y, denominator, because it's got a minus in front of it. Z, denominator, because it's got a minus in front of it. K, numerator, because it's got a plus in front of it. Now, the question is this then. Okay, where do the 3 and the 7 go? Okay, let me get rid of this stuff. Okay, so I'm talking about this 3 and this 7. Remember, using the third log rule, we can take the number that's in front of the log and put it up in the exponent. And again, I'm not going into the theory of why all this works, okay? If you want to discuss that, come on in and see me. Okay, so what do we have? Instead of just putting y in the denominator, we put y cubed, because the number in front of the log goes up into the exponent of the y. Instead of k in the numerator, we have k to the 7th, because the number 7, which is in front of the log, becomes the exponent for k. Okay, if we're going to expand using the log rules, we'll do the exact opposite. If anything's in the numerator, we'll put a plus in front of the log. Anything in the denominator, we'll put a minus in front of the log. And any exponent, we'll put in front of the log. Okay? So again, I'm going to kind of look at this backwards from what I just said. What I said when we simplified is a plus makes the quantity go in the numerator, a minus makes the quantity go in the denominator. I'm just going to do the opposite. If it's in the numerator, you put a plus in front of it. If it's in the denominator, you put a minus in front of it. So let's take a look at the x to the 5th first. Okay, the log's going to have a plus in front of it. Now you don't have to write anything because it's the first one. And I'm also going to take the exponent 5 and move it down in front of the log. So we have plus 5 times the log base 7 of x. And again, you don't need to write the plus since it's the first one. Okay, let's take a look at the second one. This is in the denominator, so I'm going to put a negative in front of it, so it's minus log base 7 of k. Okay. Just going to get rid of these for a second. Okay. Here, let's take a look at the last one. It's in the denominator, so there's going to be a minus in front of the log, and the 8, which is the exponent, is going to go in front of the log. So it's minus 8 log base 7 of m. Okay, that's basically it. Now, here are some examples. And let me just say something real quickly. The less work you show me here, the better. You'll actually understand it better, and you'll be less likely to get it wrong. Okay? Just write the answer. All right? So I'm assuming you should try this on your own. I am going to do it for you, but if you're not trying this on your own, it's not really going to help you. Okay, first of all, we're going to simplify. So we end up with one word natural log. Okay, the 3 goes in the numerator. The y to the 5th, remember that 5 goes up in the exponent. The y to the 5th goes in the denominator. Why? Because it's got a minus in front of the log. And the z, it goes in the denominator also. So we have the natural log of the quantity, and you don't have to put parentheses around it. There's a reason why. So you don't think the natural log goes to either the top or bottom. It goes to the whole thing. But it's the natural log of 3 of the quantity, 3 over y to the 5th z. Okay? And again, if you didn't try that on your own, try the next one on your own. Okay, so again, we're simplifying. So we have the log base 5. And we have some pluses and minuses, so I know I'm going to have a fraction. Okay, the x is going to end up in the numerator because it's got a plus in front of it. The y is going to end up in the denominator because it's got a minus in front of it. The k is going to end up in the numerator with an exponent of 14 because the 14 goes up in the exponent, and it goes in the numerator because it's got a plus in front of it. And the m ends up in the denominator with a 3 up in the exponent. All right? Now, let's go backwards. Let's expand using the log rules. In other words, we're not simplifying. We're given one word log, and we're going to expand this into several. Okay, anyone in the numerator is going to have a plus in front of it. Anyone in the denominator is going to have a minus in front of it. And the exponents are going to go in the front of the log for whatever the base is for that exponent. So let's take a look at the 3. First of all, it's in the numerator, so it's positive. So it's log of 3. And this is log base 10, so I don't have to say so. X to the fourth is in the numerator, so that's got a plus in front of it, but I'm going to take the 4 and put it in front, and it's 4 log of x. The 5 is in the denominator, so it's got a minus in front of it. And the y to the 9th is in the denominator, so it has a minus in front of it, and the 9 goes out in front of the log. Okay, and that's it. Okay, this one's a little obscure. This, okay, remember, x, the square root of x is x to the 1/2 power. So when it comes to doing the square root of x part of this, I'm going to use x to the 1/2 power. So we have log base 7 of the quantity, x plus 5. Now, can I take that log and distribute it? No, I can't, because a log is a mathematical operation, and you can't distribute a mathematical operation. You can only distribute numbers or variables that represent numbers. Okay, so that's the entire numerator. You can't treat the x and the 5 separately. It's one quantity. Okay, how about the 8? It's in the denominator, so I've got a minus in front of it. How about the x to the 1/2? Well, it's in the denominator, so it's got a minus in front of it, and I'm going to take the exponent and move it out in front of the log. And that's the best you can do. You can't do anything with the log base 7 of x plus 5. It is just what it is. Okay? All right. So hopefully that helps you. Again, I would not try and do it like in little steps. It's just write the answer. It's just much easier. Might be harder at first, but in the long run, you'll just save a lot of time and you'll make fewer mistakes. Hope that helps you. Bye-bye, everybody.